Guys, we're on section 1.6 now, which is called a library of parent functions. And in this section, what we want you to do is understand some very general graphs, because in the next section they're not going to be quite as general. They're going to be moved around. It's called transformations. So in this first video, that's all we're going to talk about are those basic graphs of the 8 parent functions. And actually we're only going to do, I believe, 7 in this first video. As far as graphing them with a calculator, that's something that we can do in class. I'm not going to go over it on the video here. Alright, the following graphs that you're going to see here are called parent functions. And they're basic graphs without transformations. And you'll understand more as we go through what I mean by a basic graph. As far as the transformations, when we talk about transformations, we're talking about a graph that shifts either horizontally or vertically, and they may also have a coefficient in front that make the graph skinny or fat. We're going to get more specific with that in section 1.7. But in the back of your head, because I'm going to show the form of the equation with the transformation, in the back of your head I want you to be thinking about the 3 letters H, K, and A, because in every case H moves the graph left or right. H is always the accompanying number that's inside the operation or the parentheses. K moves the graph up or down, and that's always the one that's outside of the parentheses. And A just makes the graph skinny or fat. So our first transformation, or our first parent function, is just a linear function, y equals x. You're familiar with the formula y equals mx plus b. You've covered that a zillion times since you've been in math. That's a transformation of the graph y equals x. And if you think about what that graph looks like, there's a 1 in front of that x, which means we have a slope of 1 and a y-intercept of 0. So it looks like that. Okay, the M and the B in this particular case make that graph different. And we have the squaring function, and I'm not really sure why the book refers to it as the squaring function, because it's usually referred to as a quadratic function. That's y equals x squared. And you know that to be a parabola. Okay? Now the transformation, again, we're just going to go over that very generally. This number right there, that number right there is going to move the graph left or right. This number right there moves it up or down. And while I'm writing here, I noticed that I forgot to put the A in front of that parentheses. That's the number that makes it a skinnier fat graph. So a parabola, a skinnier one is going to narrow like this, and then the fat one gets wider. If we're going to have a squaring function, we might as well have a cubing function, a cubic function. If you notice, the transformation equation looks exactly the same except for the cube instead of the square. And the parent function looks like this. One thing that you'll hear me refer to a lot in class is the 1-1 points. Okay? I refer to the 1-1 points because most of these graphs, you consider that right there to be the center of the graph, and they always, unless there's a transformation, go through a point that's over 1 and up 1 from it on both sides. And that's the case for this cube. And if we go backwards, it was also the case for the square function. From that center right there, we went over 1, up 1, over 1, up 1 on each side. Okay, so that's what I mean when I refer to a 1-1 point. Again, we're going to get a lot more specific with this in the next section. Alright, after the cubic function, we've got the square root function, which is half a parabola, laying on its side. Once again, if you take a look, there's the edge, the center, if you were to make the whole thing. There's a 1, 1 point. It's over 1 up 1 from that spot. We have the absolute value function. Now what the absolute value does is it kicks out a positive value. Whatever x is, it kicks out a positive value. Okay? So when x is a positive, 2, 4, 6, whatnot, the graph is a normal, just y equals x. When x is a negative 2, negative 4, or something like that, well then it kicks out the positive of it. And once again, if you take a look, it goes through those two 1, 1 points right there and there. The reciprocal function is 1 over x, and it's a little trickier function than you're used to. Actually, you've had it in the past, so it's not that tricky. But I had to make this graph a little bit bigger to kind of emphasize one of the points on here, and that is, once again, in the absence of the transformation, notice it goes through those 1, 1 points again. Okay? And the last one that we're going to be covering in this video is the step function, also referred to as the greatest integer function. And it looks like this. Okay? And that's a pretty gnarly looking graph, so our second video is going to be explaining the step function in greater detail. As far as what we're going to be doing with all these different parent functions, you're going to be getting some graphs in your homework, and you just have to identify what the parent function is. In other words, is it a square function? Is it a cubic function? Things of that nature. Okay, so that's the end of this video. I still don't have a catchphrase, so bye-bye.